Hi everybody! We are going to talk about ultrasonic sensors. An ultrasonic sensor, like its name indicates, uses sounds to detect at which distance an object is from the sensor. We are going to work with the HC-SR04. It is composed from a transmitter, a trigger, and a receiver. The principle is as follows. The transmitter sends sound waves, which are going to be reflected by the object toward the receiver. Then, we use the following formula to know how far the object is located. Then, we calculate the time taken by the wave to go from the transmitter to reach the receiver. Note that this distance is doubled, since it counts the forward-backward movement of the wave. We must divide the result by 2. As for the speed, we have to know the speed of the sound, which is 340 meters per second. The sensor can see between 2 centimeters and 4 meters, with an accuracy of 0.3 centimeter, on a 15-degree angle.
What is this little shade?
It means that if you walk like this, you will be invisible to the sensor. It can only see in that area.
Thank you!
Goodbye, Fly! The sensor has got 4 pins. A VCC for power supply of 5V, a GND for the ground, a trig for the transmitter, and an echo for the reception of the signal. We will just connect trig with pin number 12 on the Arduino board, echo with pin number 13. It's up to you. The VCC with 5-volt output of the Arduino, and the GND with the GND of the Arduino. We will activate the transmitter by sending an electrical pulse of at least 10 microseconds via the trig pin. The transmitter then will send 8 pulses, and as soon as it receives an answer, it will send an electrical impulse via the echo pin of a duration equal to the time made by the wave to make its way back. We will repeat these operations to infinity. As for the code, we created 3 variables. Trig, which is on the pin number 12, echo, which is on the pin number 13, and dist, that will contain the distance. We will put trig in output, echo in input, and we will initialize the serial communication. We will first make sure that the transmitter is at rest. Then, we will generate the pulse of 10 microseconds on the trigger. You notice that we used delay microseconds and no delay, which is in milliseconds. We will then measure the impulse sent by the sensor on the echo pin using pulse in. This one will wait for the signal, become high on the echo pin, then start counting the microseconds until the signal becomes low again. Then return the value in microseconds. After that, we divide the value on 58 to get the distance. Why do we divide by 58? We have 1 on 58 is equal close to 0.017. We have the speed of the sound, which is equal to 340 meters per second. It is changed to centimeters per microsecond, which is equal to 0.034 centimeters per microsecond. To calculate the distance, we have to multiply the time by the speed. But as we said earlier, we must divide the distance by 2. Speed divided by 2 equals 0.017. And finally, we display the distance on the serial monitor, and we wait at least 60 microseconds before the next measurement. We can put more here, for instance, 100. Now let's see. If you have the Parallax ping ultrasonic sensor, it has 3 pins. One for the ground, one for the 5 volts, and only one for the trig and the echo. So you guessed it, you have to put it sometimes in input and sometimes in output. It is connected with the pin number 7 of the Arduino board. As for the code, it's almost the same thing as with the HCSR04. We first put our pin in output to activate the trigger. And after that, we put it in input to receive the signal. If you want to know what the HCSR04 is made of, both eyes are made of a material called piezo. A piezo material has the particularity to deform when it receives an electric discharge, and thus produces sound waves. However, when we press on it, it produces electricity. If we return the sensor, we can find a max 3232, which is simply a TTL serial converter and vice versa. We also find 2 LM324, which are quadruple amplifiers. Thanks for watching! Thumbs up the video if you liked it, and please leave comments if you have any questions. See you later! Bye!